Today we are going to shift gears a little bit from what you're covering with Dr. Everett. I'm Dr. Yusuf Mehta. I'm a faculty in transportation in payments, and with me I have Dr. Bhauser. He is in intelligent transportation systems, and we have received a grant from the US Department of Transportation to integrate a strategic highway research program within the curriculum, within all the layers of our curriculum. It means from freshman all the way to senior year. You're one of the sophomore classes. So we are assessing how this class is going to impact your understanding of the SHARP 2. And to document that, we would like to start with a very short survey, the pre-module survey of the SHARP 2. So we are going to distribute this right away. And once you're done, we will start the class. And we will do the post-SHARP 2 survey as well. All right, the Strategic Highway Research Program 1 was from 1987 to 1992. It was a $50 million project that was funded by the US Congress. This one started a couple of years back, a similar amount of money. But the focus of SHARP 2 solutions is completely different, and you will see what that is about. Okay. All right, so this is what you're looking at, taking all the lot of research products to implementation. So this is not to develop new research products, but whatever that is already developed to fine tune it, so you can take it to implementations and directly help the state DOTs. So that's what it's looking at from objective and credible research, and they are addressing safety, aging infrastructure, and congestion. These are what you're looking at, and the idea is to work with industry and directly put in the product to use and to test it, to basically do pilot sections if it works or not. What we are looking at here is safety, where you want to reduce crashes, reduce fatalities. Another thing, you're looking at renewal, basically looking at new technologies in concrete materials, in asphalt materials, and basically some examples are like high performance concrete, accelerated bridge program, where you are coming in with very little user delay cost. You're not stopping traffic, you're getting a bridge right there pre-cost, and just checking those technologies out. Then looking at reliability in reducing congestion, and finally increasing capacity. So I'll be talking more on the materials and payment side, and Dr. Bhauser is going to talk in terms for the ITS aspect of reliability. So the focus of this class is to touch on what reliability means within the framework of SHARP 2. So here you have reliable travel time. That's one way of looking at it. Then rapid renewal, and you have better transport decisions to improve capacities, and what you can do to have safe highways. So all of these affect reliability, and one of them is looking at capacity research. That means looking at how you can tackle congestion. You either increase lanes or optimize your configuration, provide appropriate applications to reduce congestion, and how we can predict congestion. That is also one part of reliability. Now I'm going to get off the slides, and I'm going to talk about reliability in payments and materials. And once I'm done, Dr. Bhauser will talk about more on the other aspects. So why reliability is important, I want to focus on that aspect today, and what it means to in payment design or structural design. So for example, you're doing a concrete test, right? So you're looking at concrete materials, right? And you are asked, as a concrete manufacturer, to make a concrete sample of 3,000 psi. Okay? Right here. Okay? Now when you go out in the lab and you mix your mix your water, cement, aggregates, and you try to target your 3,000 psi, right? 3,000 psi is the compressive strength. You apply in compression, and you look at it at failure. When you are testing this cylinder in compression, right here, and you break the sample, okay? and you get 3 samples, you do 3 samples, numbers are 2500, 3000, and 3500 psi. Okay? What is the risk the client is taking if you take the same mix with this data available to you? Anybody? What is the risk? Yes?
You might end up giving them one that only goes up to like 2500 or
Right.
750 or something.
That's right. So you did 3 samples, your client asked for 3000 psi. What is the risk the client is incurring? What is the reliability of your measurement? Anybody? Yes? In terms of percentage, what is 500 psi? Let's look at this. So right here, you have one data set right here, right, at 3000 psi, right? And one of them is right here, lower, and one of them is lower, right? If I do the same practices, keep doing the same practices, and I do instead of 30 samples, what is it going to look like? How many of these data points are going to be less than 3000? How many are going to be above? Yes? About the same amount, right? So you will, if I go with the same from 3 to 30, I will see something like this. A bell curve, a distribution. What does it mean? What is the risk now? Having told you, you did hundreds of samples, now can you tell me what is the risk client taking? Client asked for 3000. What is the risk the client taking by they accepting this product? Anybody? 50%. 50% of the data is below and 50% of the data is above. So you have 50% chance of getting it right. And your client may not be happy with this. Right? Your reliability is very low. Right? So now, if you use the same data set and the client says, you know what, I'm not going to take that 50%. I need 90% reliability. That means I want to take only 10% risk. That is what this reliability is about. I want to take 10% risk on the product. What will I have to do? Anybody? What will I have to do? Yes?
You'll have to move it so that there's only 10% to the left of 3000.
Exactly. So when I say I have to move it, basically what would I have to do? What am I doing? You're absolutely right. I will have to create, if I keep the same bell curve, my same quality control, I will have to move this, my target at 3000 will not work. Correct? So I will have to move it by 1.34 times the standard deviation. So something like this, where now the same width, that means I have not changed my quality control, and the same width I have to move it to the right by a certain amount. And that is, if I'm taking 10% risk, I want only 10% of them below my target 3000. And this could be 4500. I'm just throwing a number out there, 4500. Implications for you, anybody? Me doing this, what have I done? Anybody? What have I done? Anybody? I bumped it up. How is this going to affect me as a supplier? Anybody? Yes?
Higher cost.
Higher cost, right? So I will have to increase my cement content, improve my quality, and that you will have to eat up this cost every single time. Right? How else can I, so every time I have this bell curve, I am dealing with 50% reliability. How else can I minimize this cost? All the time. What else can I do? I have to bump this up. How would I make this jump from 3000 psi to 4500 psi a little less so I can reduce that cost? Anybody? Yes?
You could make your process more precise.
Exactly. You can focus on quality control. So now I'm taking 50% risk, right? And you have a bell curve. Remember, this is approximately 1.34 times the standard deviation. So the breadth of that curve is causing me to move this to the right a lot more. Now, if I have a very tight control, instead of 3000, I have 2990, 3000, and 3010. Right? Now you are very precise. You are paying attention to details, and you have this tight control. Right? Now your bell curve is significantly thinner, and now the same thing, 3000 psi, I cannot still give 3000 psi to the client. Why? Why can I, this is still not sufficient. Why? Because this would still be 50% risk. The client said 10% risk. Therefore, I will have to move this to the right, but now I don't have to move a lot. Correct? So instead of 3000, you are going up to 3050 or 3200, much less than 4500. That change is going to save you money on the long run every single time. So you paying attention to this bell curve and will allow you to offset that. Any questions for me? So this has serious implications, and that is why these things can come from user variability, testing variability, construction variability, environmental variability, right? All of these can cause this bell curve to go up or go down. Right? So you have all these processes, and you are looking at these variability, and the way you can minimize them by having people trained, you're lab certified, you have quality control processes in the lab and in the field that will keep this risk pretty low. Everybody with me? So that is one aspect of reliability that is very critical at all times when you do materials design. Yes, questions? Now one more thing I'll pick on is pavement side. So this is on the material side. The next one I'm going to talk about why is this variability and this distribution so critical on the pavement side. Let's look at this. Now I'm going to shift gear from the materials aspect of it to the design of pavements. Okay. Let's look at this. You are looking at a simple structure. You have your natural soil. Okay. And I'm going to look at one single layer. Okay, just one layer for simplicity. Okay, and let's pick one layer, and you want to design the right top layer, either it's hot mix asphalt or asphalt concrete or any other. So your goal is to get the right thickness, right? The right thickness of the hot mix asphalt or the right properties, like the Young's modulus of elasticity that you guys learned about that. Did you guys learn about Young's modulus of elasticity? Okay. Let's look at this. So my goal is to get the right thickness and the right stiffness for a particular soil. In the pavements, as a non-designer, can anybody tell me intuitively what will affect these values? I'm looking at a layer. Let's say this is going to be constructed just outside Glassboro, right? And you have natural soil. What do you think will influence this thickness and this stiffness? Just throw some ideas out there. This is a roadway, Route 322. Anybody? Anybody? Yeah, one thing is traffic, right? You're trying to, you're looking at traffic, right? And you guys took my intro to infrastructure. Were you guys there in my module for intro to infrastructure? Dr. Dusso, you talked about payments protecting. So one is traffic, right? What else? Anybody? What else do you think would impact this thickness or this stiffness? Yes?
Soil.
Excellent. The properties of the soil. What else? One more. One more. Will it be different? Like it's in Glassboro. Obviously, I'm leading you to the answer. Minnesota, Florida, right? It's going to be different about what material you select. So another aspect is environmental effects. So this is the three things that is looking at environment, traffic, and soil properties through that entire. Couple of things to keep in mind. You are designing for something that is 20 years out, right? So you're designing today what is going to last until 2035. So this is all about projections. It's all about knowing what it's going to be ahead of time. So everywhere, do you have a single number? No, you have soil properties that's going to have a certain variability. Traffic, you are looking at certain variability there as well. Environment, nothing is known. You are estimating a certain risk and you are going to assume that there's going to be certain variability in the environmental temperature range, rainfall, and so on and so forth. So each of these are not a single number. Cannot be. Everybody with me so far? So what is, every time this gets broader, that means what? I have, when this gets broader, what is intrinsically happening to these numbers? I have
More uncertainty.
more uncertainty. You're absolutely, I have less confidence in these numbers. Every time I have less confidence in numbers, that means I have to account for something that extreme or these extreme versus something that is like this. How will it impact your design and selection of this? Anybody? The wider this curve is, what is going to happen to these values? Yeah, you'll start to apply a factor of safety on it. So the more uncertain I am with these, your E values and the thickness will move in the direction to cover a broad range of values that will make it more expensive. Point being that if I pay attention in data collection of all of these, in the long run, I don't have to increase my thickness 1 inch, half an inch every time. There's only scarce dollars to go around. You have to make sure you use it wisely, and you want to make sure you get the right thicknesses, and every time you have uncertainty here, you are going to just add a couple of inches of thickness all the time. That is a long-term impact of not the reliability of your design. So if I have 90% reliability and I go from 90 to 95, given this variability, immediately your design will tell it to bump it up by a couple of inches. Makes sense, right? Logically. With that, that's what I have on the payments and material sides. And then I just erased this. That's good. You want to take this? Okay. But I think you need it for that, right? You need.
Yes. So I'm going to talk about travel time reliability. So how many of you know about the bottleneck near 42, 55 and 295? And even if you don't know about that bottleneck, everyone has some memory of one of the intersection near their home, right? That is always congested. So that is what this slide is talking about. This is what you go through during a year. If you look at the daily, I don't have a daily graph, but if you look at the daily distribution, you have peak hour in evening and morning. But you always remember the peak hour. You will not remember that smooth time in the early morning or afternoon, after the lunch time. But this is what we were communicating up till now, annual average. And travel time reliability project talks about that if you are going to the airport, you know that typically it takes 30 minutes, but if there is an incident and if it's more than 30 minutes and you don't calculate that buffer time, you may miss your flight, right? So travel time reliability project is talks about that. They develop models and everything that I'm going to explain. But this is the concept of travel time reliability. The main thing the research found out is about the 7 parameters that affects travel time reliability. Of course, first thing is incident and weather, and then you have a work zones. Fluctuation in demand is also there. If you have a football game compared to a normal traffic, there will be a different travel time for the same intersection. That is special events and fluctuation in demand. It's because of special event. Another thing is traffic control device. Everybody knows about traffic signal, right? Inadequate base capacity. That is what is happening with 42 bottleneck. We don't have a base capacity for the current traffic. That's why New Jersey DOT is spending millions of dollars to improve that interchange. So the current focus right now, the past focus was to find out this average time. But the current focus is to find out this variability and inform travelers about this variability. Travelers, engineers, planners, whoever is working on developing the future infrastructure or traveling the current infrastructure, using the current infrastructure. So this is project is titled Reliability in Travel Time, and the number is L04, and you can look at the entire document. But the primary objectives were determine how travel demand forecasting models can use reliability measures and develop a scenario manager and vehicle trajectory processor to incorporate reliability metrics. And you must be wondering, what are these? What is travel demand modeling? What is scenario manager? What is vehicle trajectory processor, right? So let's go back. First of all, what is demand? So demand is willingness to buy. Number of customers are willing to buy certain things. Now demand changes. This is where your variability. Demand changes based on individual's desire, right? Somebody may want all three of these and someone just wants smartphone, right? Another variable, important variable, is supply. Supply is number of customers can buy. Can you supply this? And when you meet supply and demand, that's where you have equilibrium. So now people in Glassboro wants 100 Tesla cars, but if I am a supplier, if I cannot supply that, the system is not under the equilibrium. So that's why we want to forecast demand. If you know that after 5 years from today, people in Glassboro will be driving this many hours per day, there will be certain percentage of increase in population. If you know this very accurately, you can model the system for the future, right? So that's what travel demand forecasting is. You try to forecast demand for future. Planners, transportation planners use these models to forecast demand for next 20 years. And then they include all the development, future development, and they publish a report that is called a Transportation Improvement Program for the city. This typically metropolitan planning organization develop these reports. It's called TIP, Transportation Improvement Program. You can look it up for the Southern New Jersey planning. So why we not, I'm just putting this slide again, why we need to do travel demand analysis? Because we want to find out for future whom this planning is, for whom, how many, and how much. We can answer questions like how many people will use this facility, how much money will be required over the span of 20 years. Purpose, long-term transportation planning, transportation impact study of a new development. We want to do all this. That's why we want to forecast demand. Long-term transportation planning means you want to develop your plans for next 30 years. Impact study means you want to see if Walmart is coming in your neighborhood, how the traffic of Walmart will impact particular intersections. That is transportation impact study. And what is scenario? Scenarios are, you have a current condition that you don't have Walmart. Now next thing is, you know that Walmart is planning to put a facility here, so that will be the future scenario. But then you have to figure out how many people will use Walmart, and based on that you may end up developing multiple scenarios that, okay, what if this Walmart gets really busy? What if you have additional facilities like Lowe's or Home Depot with Walmart in the same area? So that is your scenario. So, and they develop a scenario manager that I will explain how that will help the future. So this is a typical 4-step travel demand modeling system. So it starts with this system like any other project. It starts with data collection. So population and employment forecast, land use patterns. You have to know how many people are staying here right now, and what is the likelihood that people will stay in this neighborhood, and the other businesses will attract more people to stay in the neighborhood. Population increase. How can you find it? Government every certain year government does a survey. It's available, the data is available online. Census data, if you search in Google census data, federal highway or census data, US government, you will find that website, and you can use that data for any kind of prediction. Other thing is employment forecast. So for these, you have to find out current employment situation in your neighborhood. Next is if Walmart or some other facilities are coming into your neighborhood, and how many people they will employ. Land use pattern. So if you are moving certain things, if you are changing a parking lot to a condo facility, how that will affect. Once you have all this data, the first step is trip generation. So you try to estimate how many people will stay here, how many people will go from this point to this point, this origin to this destination. How many people will go, for example, if you have a clear like east side is, for Rowan, when the classroom change, you will have more traffic at the lunchtime on 322, right? So that is a trip from East Campus to West Campus. So you try to estimate the same thing for entire neighborhood. The next is trip distribution. You try to distribute this thing. That okay, when you will have Walmart will have 100 people every day from 8 to 5. That is your generating, but they will in the morning they will start from their home and go to Walmart. In the evening they will go back to their home. So that will be the distribution of trips, right? So you have to estimate this trip distribution. Next step is mode split. So what they will use to, whether they will carpool, they will use bus, they will use bikes. So how do you estimate that? There are models for that. And then once you have all this, the last part is what route they will take. And that's where the travel time will come into play. And the output for this model is flow, times, and cost. Flow is vehicle per hour. How many vehicle per hour will be there on 322 in peak hour? How many vehicles per day in an entire month? Or in average, there is something called average annual daily traffic. So how many people will travel daily on an average? Another thing is you will get times and cost. If you have, you can convert some of the things into cost. How do you use this model? Once you have great project, the great model for the base condition, you can put more future expectations. You can put that, okay, what if in addition to Walmart, somebody after 5 years develops a residential neighborhood near the Walmart? What will happen then? If you already have in progress from the Congress that, okay, they are going to invest such and such money in this area, how that will affect the trips. Once you have that, you can project same flow and times and trips for future, right? Once you project the trips, you know that, then you can find out that, okay, yeah, right now this 2-lane highway is good, but in future it will not be good. So we may need to add one more lane. So now that additional lane costs such and such money today, but we may need this after 5 years. So you can put this together, this entire plan, how much money we need over the span of 20 years. Now, is this constant? Is this fixed? No, right? Because you don't know what will happen after 5 years in Glassboro. Right now you are estimating based on the current data, but you don't know the future, right? So that's why this variability comes into a picture, and that's why we need to improve trial time reliability. So coming back to this slide, now you know what is travel demand model and what is the scenario manager. Vehicle trajectory processor you get vehicle trajectory, speed information at every second from simulation models, and you use that to find out the distribution of travel time for a particular roadway, and that's where you get the same chart that Dr. Mehta was explaining, and then you try to see if you can capture that reliability. Another thing I want to explain is buffer time. So buffer time is, on an average it takes 30 minutes, but because of incident you may need to add 30 more minutes, so that 30 more minutes is your buffer time. So if you know this variability, if you have some kind of estimation of this variability, you will plan your trip accordingly, right? So now you know that, okay, I don't need to go half an hour early, but I need to go 1 hour early so that I can account for that buffer time and I can catch my flight on time, right? So how do you do that for current models and future models? How do you do that? So current practice was that you just create this scenario based on the data and manual estimation, like from engineer, that okay, this Walmart will be there, this is let's do this scenario, but again it was not included, weather parameters were not included, the incident parameter were not included accurately. So what this research focused on two types of variable, exogenous and endogenous variable that affects travel time. Now this is a big word. Exogenous means independent variable that affects travel time, but it is not affected by the model or by the trial time model. Endogenous variable means dependent variable that's in the model that affects travel time and it is affected by the model, so it changes based on the model. So they research about that, then they did scenario based analysis, and they use something called traffic simulation model, micro simulation model. Now what is micro simulation model? Micro simulation model is a model that can calculate position of each individual vehicle on a roadway using some mathematical modeling. I'll not go into a detail, but the idea is that if instead of knowing an average speed on a roadway, if you know speed distribution or time distribution for each and every vehicle of that roadway, your estimate will be better, right? This is same as having more data for concrete or pavement, as Dr. Mehta explained. So that's why they used simulation model. They model current scenario, then they varied multiple scenarios based on weather, what if we have incident. These are called what if scenarios. So what if we have incident only on one lane and one lane is blocked, but you still have it's a 3-lane freeway, so you have 2 more lanes. How that will affect travel time? Instead of that, now next scenario can be, what if we have all 3 lanes of one direction is blocked and everybody has to use alternate route for next 1 hour? How that will affect the travel time for the entire neighborhood or network. So after modeling this scenario, now you have a very good distribution of travel time, right? So you feed back that to the system. Now what is happening here, you have this data, so for next time when you want to model for another neighborhood, you know certain variability, you can generalize this model. So this was the current, this is the current practice. You have project or policy to be evaluated. You want to evaluate what if we do for 42 bottleneck, 42 295 bottleneck, what if we just add one more lane? Because that is cheaper than redoing the entire interchange. But again, the scenarios, these, what I said, it was manual specification. Okay, this was just, okay, this is what we want to do. So then we put this thing in models. Then we predict the performance that, okay, if you put one more lane, this is how you will save in time, this much will be the time saving, all that thing. And then based on that, the decision is taken. Now this does not cover all the variability that we want to do. So the better approach is you do that, but you have this something called scenario manager. What is this? It has a library or knowledge base. So it has multiple, it has information about weather variability, it has information about incident variability, it has information about some other fluctuating demand, spatial event. Once you have that, you can develop multiple scenario that is critical to particular neighborhood. So the system scenarios are generated by system identification and automatically. It's not like, okay, because I know better, let's do 3 scenario. Okay, it's not that. It considers all variability for the particular neighborhood. Now once you, the main thing is you, after you have this variability in number of scenarios, you can model this in this softwares and you predict the performance. You run multiple times and then you do based on you can do multiple analysis, you can do benefit cost to figure out, okay, even though this is better, it requires this much money, but we are getting so much benefit, so it makes sense to do this in a near future, something like that. Now the 2 things are happening. One is it helps you to make a better decision, or I would say optimal decision, because you consider most of the variability. Another thing is you can feed back all that scenario that you model into this library, so the data becomes richer and richer. So this is a feedback loop. So every time you are modeling these scenarios, you are increasing the knowledge base, you're increasing the data in the library. So next time when somebody will use the same thing, it will have more variability, it will consider more parameters. So there is a software, they developed 2 software. One was scenario manager. They had case studies, and for those case studies they model multiple scenarios, and now it is available online. Unfortunately, it is not working on my computer. I wanted to show it to you, but it's giving me some error to show existing scenarios they have. But it's freely available, and I'll show you how to download it. I'll show you some other tools also from this product, from SHRP. And the future direction is you incorporate data mining. So you in addition to the scenarios that you are building for getting more information from the model, you incorporate more data from something called crowdsourcing. You incorporate more data from the smartphone usage, from the social media usage, social network usage, and you try to see how the travel time variability can be understood from those data. So finally, what we want is reliable and valid assumption for travel time. We don't want for just one particular area. It's valid, it's reliable, but it's not valid for every intersection and neighborhood. We don't want unreliable. It's valid for each location, but it's not valid for the neighborhood. So let me show you the softwares. So I want to show you the website that has most of the product. Okay, so this is the main website, econ-works.org. Let me just write it here. And as you can see, this website has three main products: PlanWorks, TravelWorks, and EconWorks. And this each, I'll just show you some of the things available. This is a very good website if you want to, if you are working as a transportation engineer, and if you want to go through the entire process of developing, let's say, long-range transportation planning project, or you're working on corridor planning project and you don't know where to start. So it gives you step-by-step instruction how to do it, what parameters should you consider for this particular project, whom should you talk to from federal level to the local level. Everything is there. I want to show you this thing, it's application. As you can see, there are multiple applications available. Now each of this is a result of SHRP program. And some of these has a report, some of them have as a tool, and we will I can show you the performance measures. So what are performance measures? You know that, okay, you want to plan corridor, this entire 322 corridor, so that one university student can cross it easily, and traffic also improves, traffic condition also improves, right? So how do you do that? What variable should you consider? So there is a diagnostic tool available here. You can use that. It's a simple questionnaire and it will give you detailed explanation. Where is your project preliminary located? In an urbanized area. Okay, if you go through this, it will give you, let me just put it here. So operational challenges, let's say it's in a known potential habitat. It will give you all this list, that what parameters you should consider to measure the performance for each and every scenario. Okay, let's go back to this website. Is really good. You can read about this resource and it will give you the detail. See, if you click on the report, it will this is not a good, but it will link all the websites, all the reports, all application to a actual research report that experts submitted to highway program. So if you can use just the small questionnaire tool and just go from there, or if you want to find out in a detail and work on that, you can go and read the entire report. Okay. Now about the reliability, there is one more tool about reliability. It's in EconWorks. If you click on project and analysis tools, there is a tool for reliability. It's an Excel worksheet. What it does, it gives you this simple user-friendly tool to calculate benefit cost for your project. You come up with some scenario you model all these scenarios, and then you say that, okay, it will improve 10% travel time, or it will do this. Now how do you put that into information that is readable by everybody? You guys are engineer, but you will not you want to inform everybody, right? And they may not be engineers. You want to inform politician to general public, everyone. So how do you do that? So if you convert everything into dollar value, it helps. It will help you, right? So let's see. So here you can create scenario for different facilities. You can put description, you can put analysis period, all this thing. And see, the main thing here is, if you have enough data, you can put this time, that travel time unit cost $10 per hour, commercial $15 per hour. So it's a cost for travel time, for personal cost for travel time. So if you spend 1 hour in the traffic, if you lose 1 hour in a traffic, you're losing $10 per hour. Now these numbers, they also have some default number that you can use. And if you click result, it gives you something called travel time index. This TTI means travel time index. What does this mean? It gives you that index or ratio of, it compares free flow travel time. Free flow means where you have 0 to almost no vehicle. What will be the travel time compared to the travel time in the different situation in your scenario? And it gives you that index. It also gives you money. It converts based on the number you put in, total annual weekday congestion. This is total equivalent delay, recurring delay, incident delay. This is one of the tools. There are 2 other tools, scenario manager and trajectory processor. Once you develop a simulation model, you can put the output of that model into processor and that scenario manager, and it will give you different options that, okay, these for your condition, this may be the variability. You can it will recommend that you simulate certain scenarios. Once you do that, you can put it here and you can find out these delays for each. Okay. So this is one. And there are some other tools. Each tool, as you can see, it has a user guide. It will give you, this user guide is also part of the main report. This reliability tool was a part of project C11. What I talked about is in scenario manager, that was a part of L04. But both of them falls under that main thing, reliability. Main focus area of SHRP2. And there are some multiple tools available for other focus area and reliability. And you can look it up on this website. If you search SHRP, where is the? If you search SHRP education connection, and solutions, it will give you all this area, and you can, this is a very big website. It will give you all the product that they have, safety and risk management, safety solution, urban freeway models. There are a lot of things based on your area. You can browse this product. Each product has a report. If they have as an objective to develop a tool for implementation, it has that. Again, as Dr. Mehta said, this is the second phase of the SHRP2 product. We have to, the main objective was that how to implement the research, the fundamental research that has been done in the first phase. Any questions?
If you're interested in the links, we'll send it to Dr. Everett and he can distribute all the links to the website.
Any other questions?
No question. Yeah. So yeah, that ends the session. Now please fill out the second survey.